I'm recording. Thank y'all for reminding me. We actually have already solved by graphing, but on the outside of your door, write solve quadratic equations. That's abbreviation for quadratic equations by graphing. All right. Open it up, and we're going to do 3 examples on the inside of that door. So if you can, I'm going to kind of open this up so y'all can see that you might not need to write really, really big. Y'all looking? Don't write really, 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 really big. Okay? I don't know if you can use a marker or not. So we're gonna go through. Y'all see that? Okay. So example 1. All right. Now you're opening up your door to your foldable. Example 1. If you are at home and you're listening to this because you didn't come to school today because of the weather, then you're just going to write this on a sheet of notebook paper. It's okay that it's not on a foldable. Just write it on a sheet of notebook paper. So number 1, if we were solving x squared plus 5x plus 6 equals 0, and by the way, when we're solving, even if we're graphing, our equation is set equal to 0. So some of y'all said, why are some of these set equal to 0 on your last test? They always set the equation equal to 0 when you're solving. So you did this on the last test. You started out with x is equal to negative b over what? 2a. 2a. Okay. What is b in this equation? 5. But if the equation says negative b, then you're going to put in a negative 5 divided by 2 times a. A is 1. That's going to be negative 5 divided by 2, which is negative. What's negative 5 divided by 2? Negative 2.5. All right, if you're graphing, what do you do with negative 2.5? You put it in the middle of your t-chart, says Gracie. You put it in the middle of your t-chart. Then you pick 2 x's that are smaller than negative 2, like negative 3 and negative 4. You pick 2 x's that are larger than negative 2.5, like negative 2 and negative 1. Then you pick up your handy-dandy calculator and you plug all those x's in. I'm just going to tell you what you get here. When x is negative 4, y is 6. When x is negative 3, y is 0. When x is negative 2.5, I didn't put one there. I don't know why I didn't put one there, but we'll just skip it for just a minute. It's negative something. When x is negative 2, y is 0. When x is negative 1, y is 6. Okay? And then we sketch this graph out. We're just going to sketch out. And the main thing we're looking for is where the graph crosses the x-axis. I think I was just trying to say all we're really looking for is the negative 3 and the negative 2. So I guess I said it really doesn't matter how far I go down because I know that the graph's going to cross the x-axis at negative 2 and negative 3. So your solutions would be x is equal to negative 3 and x is equal to negative 2. Everybody remember doing that? Bless you, bless you. Okay? Now, 3 different things can happen when you're solving by graphing. This is one of those 3 things. 3 different things can happen when you're solving a quadratic equation by graphing. One of the things that can happen, which is happening right here in example 1, is that your parabola can cross the x-axis how many times? 2 times. One thing that could happen is that your graph crosses the x-axis 2 times, and so you have 2 solutions. Now, we're not going to do another full-blown equation, but let's just pretend. Let's just go to the graph part. We've already done the negative b over 2a reminder, put in the middle, pick less than, greater than, make the t-chart. All right, what's another thing that could happen besides the parabola crossing 2 times? It could just cross 1 time. So let's just draw one that crosses just once. So if your parabola is just sitting on the x-axis or hanging on the x-axis, if the parabola were going down, then you wouldn't have 2 solutions. You would only have 1 solution. And in this beautiful picture, the solution would be x is equal to 4, right? Because the parabola is crossing the x-axis at positive 4. All right, so again, there's three different things that could happen. Now we've looked at two of them. You could have two solutions, you could have one solution, or you could have, okay, not just no solution, but no real solution. What's the graph going to look like if there's no real solution? It's never, ever, 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 ever going to cross the x-axis. So it could look something like this, where the parabola has a vertex above the x-axis and it's going up. Or it could look like this one, where the parabola is going to go down and the vertex is below the x-axis and it's never, 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 never going to cross. And that's when we say we have no real solutions. That means the solutions are really what? Imaginary. But where do you learn about imaginary numbers? In Algebra 2. And door number 2. Okay? Behind door number 2. So one of your other doors, we're going to write solve quadratic by quadratic formula. Now I want you to write this kind of small, because we're going to actually put the quadratic formula on your door. So write it kind of small at the top. Solve quadratic by quadratic formula. We can solve quadratic equations by formula. How many of you usually think a formula is fairly simple? I do, because a formula is kind of like a recipe. If I have a recipe to go by, I don't have to create something. I can just follow the recipe. 1 cup of Crisco, 1 cup of white sugar, a half a cup of brown sugar, 2 eggs, and a teaspoon of vanilla. Mix all that up. Anybody know what I'm making? Ice cream. I'll keep going. Once I mix the Crisco, the white sugar, the brown sugar, the 2 eggs, and the teaspoon of vanilla, then I'm going to add in 2 cups of flour. Then I'm going to mix that in. Nobody has said it yet. This is going to be the last clue, and everybody will know. Once I mix all that together, I'm going to pour in a cup of chocolate chips. Chocolate chip cookies. Okay? So a formula is like a recipe. It tells me exactly what to do. It tells me how much to put in. It tells me when to put it in, because you want to cream the Crisco and the sugars and the eggs together first before you add the flour. So the quadratic formula is going to tell you exactly what to do. So it says negative b plus or minus big square root b squared minus 4ac all over 2 times a. Alright, so you may be wondering, where does the a, the b, and the c come from? It comes from your quadratic formula, your quadratic equation, being in standard form. So in this situation, standard form means your equation has to be set equal to 0. We mentioned that earlier. Anytime we're solving, okay, when you're solving by graphing, your equation is set equal to 0. So your a then would be the number in front of your x squared, your b would be the number in front of your x, and your c would be the number that doesn't have an x at all. And then you take these a, b, and c values and you put them in that formula, and it solves the equation for you. It's going to come out to tell you what your x values are. If you'll open up that door, we have 3 examples. And we're going to kind of keep a running number here. So you're probably going to, you may even have to go to the back of your foldable here, because you might not have enough room. You may, it depends on how small you write. Okay, so example 4. If you're given the quadratic equation, x squared plus 5x plus 6 equals 0. I think we've already solved this one today. This was example 1, but we solved it by graphing. Now we're going to take the same equation just so you can see how you can solve it a different way. And we're going to solve it by using the quadratic formula. So either in your head or on your paper, you're going to want to identify what a, b, and c are. You don't have to write these down. Some of you can just think in your head. A is what? 1. B is 5. And C is 6. Okay? You don't have to write these down, but in order to find A, B, and C, your equation has to be set equal to 0. Now, according to the quadratic formula, it says x is equal to negative b. That means the opposite of your b. So right now your b is positive 5. So when you put it into the equation, it's going to become a negative 5. And then the formula says plus or minus big square root. It says b squared. Always put that in parentheses. Minus 4 times a. Always put my a in parentheses. Times c. Always put my c in parentheses. All over 2 times a. Always put my a in parentheses. Anything that I'm plugging in is extremely good practice for you to put parentheses around it. Alright, now we're just going to work through the formula. So underneath the square root, I have an exponent, I have a subtraction sign, and I have a bunch of stuff to multiply. Order of operations say I do what first? Multiply? Okay, so is there anything to do in parentheses 5, parentheses 1, parentheses 6? No, so then I go to the e. What does the e stand for? Exponent. I do have an exponent. Please tell me that 5 squared is not 10, but it is 25. Then I bring down the subtraction sign, and then I multiply. 4 times 1 times 6 is 24. You've got to multiply before you can subtract. All over 2 times 1, which is 2. You're going to continue to simplify everything that is underneath the square root until you get one number. We don't have one number yet, so let's continue to work under the square root. So 25 minus 24 is 1. So I just simplified 25 minus 24 down to 1, and then I have negative 5 plus or minus the square root of 1 divided by 2. Now you simplify the square root. That's why we did the homework. So what is the square root of 1? Is it a perfect square? Is it a perfect square? Yeah. So what times itself is 1? 1. So the square root actually goes away because the square root of 1 is 1. If that said the square root of 4, then you would put a 2. If that said the square root of 9, then you would put a 3. If that said the square root of 16, you would put a 4. So the square root goes away because the number underneath it is a perfect square. But we still have to divide by 2. Alright, last step. Now, I'm going to get 2 answers here because my formula says I've got to do negative 5 plus 1 divided by 2. That's going to give me one answer. So what's negative 5 plus 1?
4.
Close.
Negative 4.
Negative 4. And negative 4 divided by 2 is?
Negative 2.
Negative 2. So that's how I get one of my answers, by doing the plus 1. You've got to do plus 1, and then you've got to come back and do minus 1. So my first answer comes from the plus 1. My second answer is going to come from the minus 1. So I'm going to do negative 5 minus 1, still divided by 2. Negative 5 minus 1 is negative 6. And negative 6 divided by positive 2 is a negative 3. So my 2 solutions are negative 2 and negative 3. Okay? Now, do you have to show every single step? It just depends on what makes sense to you. Some of you are going to skip a few steps. That's great as long as you can continue to get the right answers. If you're missing the answers, then you need to go back and show more steps. I'll just have to leave that one up to you. Okay? All right, let's look at example 5. Example 5, this is going to show you how you can use the quadratic formula and get only one answer. So let's look at x squared minus 4x plus 4 is equal to 0. Your equation has to be set equal to 0 for you to find your a, your b, and your c. So either in your head or on your paper, you're going to write a is what? 1, b is negative 4, and c is positive 4. Alright, then let's use our formula. Our formula says x is equal to the opposite of b. So b is already what to begin with? Negative 4. So the formula says negative b. So that says the opposite of your b. So if your b is negative 4, in the formula it's going to become positive, plus or minus big square root. Put everything in using parentheses. B squared minus 4 times your a times your c all divided by 2 times your a. Then you're going to go to work under the square root. That's what you're going to do. You're going to attack what's under the square root. You're going to do the exponent first. What's negative 4 times negative 4? 16. Okay? Do you know you're always going to get a positive number when you square something? Even if you square a negative, you're still going to get a positive. Okay? You're going to bring down that minus sign. You're going to do 4 times 1 times 4 in your head, and you're going to get 16. So now you got 16 minus 16 all over 2 times 1, which is 2. You're still going to attack what's underneath your square root. You still got something to do. You got subtraction to do under your square root. So that's going to end up being 4 plus or minus the square root of what? 0, right? 4 plus or minus the square root of 0. Now, when I say is 0 a perfect square, we may not have written it down as a perfect square, but it technically is a perfect square because 0 times 0 is 0. So when you take the square root of 0, you're just going to get a 0. So you get 4 plus or minus 0. The square root goes away because technically 0 is a perfect square divided by 2. Now, this is the only time you're not going to add 0 and subtract 0 because I don't know if y'all knew this or not, but 4 plus 0 is 4, and 4 minus 0 is also, is it? It's just 4. Think about that. 4 plus 0 is 4, and 4 minus 0 is also 4. So you're not going to end up with 2 answers here. You're only going to end up with 1 answer because of the 0. So you're just going to end up with 4 divided by 2, which is 2. So when the number underneath your square root in the quadratic formula comes out to be a 0, you're only going to have one solution. That would be an example of using a quadratic formula where you only have one solution. Alright, so does anybody have any idea how you would get no real solutions after just looking at 2 of these? If it's not a perfect square, well then why did we learn how to simplify square roots that didn't have perfect squares? Come on, I know somebody can turn your brain on and really think about this. What would you have underneath your square root if the answer were no real numbers? What? When you have no b? No, that's a good guess. Anybody know what we can't take the square root of? Say it louder. A negative. Can we take the square root of a negative number? Have y'all ever thought about that? Ah. All right, let's look at example 6. All right, 2x squared plus 3 is equal to 0. Remember again, if your equation is not set equal to 0, you have to set it equal to 0. What is your a value? 2. What is your b value?
30. Oh wait, we don't, is
0. Good. We don't have an x, so that means our b value is 0, and our c value is 3. Okay? Now, I don't want you to think that the problems that don't have real solutions, I don't want you to think that the b is always 0, because that's not true. Okay? So you can have a b value and still get no real solutions because they're imaginary. So don't think that just because the b is 0, that means that's when we always have no real solutions. That's just a coincidence. I just wanted to remind you that when you didn't have an x, your b was 0. So let me show you what's going to happen here. So according to the quadratic formula, we're going to do negative b. Well, guess what? B is 0. 0 is neither positive nor negative. So when you do negative 0, you still get 0. So 0 plus or minus, fill in your formula, 0 squared minus 4 times your a times your c, all divided by 2 times your a. All right, and we're going to go straight to what's underneath that quadratic formula. And by now, this is the third time that you've worked through one of these. You're going to square the 0 and get what? 0. You're going to bring down your subtraction sign because you can't subtract until you multiply. And what do you get when you multiply those three numbers together? 24. 4 times 2 is 8. 8 times 3 is 24. Y'all didn't need a calculator for that. And what's your denominator going to be here? 4. All right, what do we do next? You finish doing what's under the square root. So what number is going to end up being under the square root? Negative 24. All right. In Algebra 2, you're going to learn in a lot more detail that the square root of a negative number is always an imaginary number. Okay? Nothing times itself, guys, can ever be negative. So the square root of a negative number can never be a real number. It has to be another complete set of numbers in itself, and those are the set of imaginary numbers, and you don't know about those yet. So as soon as you get a negative underneath your square root, you're going to stop and you're going to write no, okay, no real solutions. There are solutions, we just can't find them yet because they don't want y'all to know about the set of imaginary numbers yet till you get to Algebra 2. There's enough to learn right now. You'll learn a whole lot more once you get to Algebra 2. But as soon as you get a negative, and these are your notes, so, you know, hey, pay attention, negative, 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 alert, alert, alert. Can't have a negative underneath that square root. That means there's no real solutions. Okay, I've got one more. If you don't have enough room, flip it over on the back of your foldable. This is the last example that we're going to do. This is the last example we're going to do. Anybody still copying example 6? All right, last example, example 7. I wanted you to see an equation that was not set equal to 0 to begin with. So let's look at 7x squared is equal to negative 6x minus 1. If your equation is not set equal to 0 to begin with, then you have to take the negative 6x and move it over to the left-hand side. You got to take the negative 1 and move it over to the left-hand side and make the right-hand side completely empty so we can put a 0 there. Now, y'all have come through enough math that I want y'all to use this shortcut. When negative 6 travels over to the left-hand side, it's going to become a positive 6x. When negative 1 travels over to the left-hand side, it's going to become a positive 1. So when a term changes sides, it changes signs. When it changes sides, S-I-D-E-S, it changes signs, S-I-G-N-S. Then we know that A is 7. Either in your head or on your paper, write it down. B is then going to be positive 6, and C is going to be positive 1. A is positive 7, B is positive 6, C is positive 1. All right, let's work through the quadratic formula. X is equal to what? Negative 6 plus or minus big square root, and then you're just plugging into the formula. You'll get pretty good at this. The more you do, the better you're going to get at it. Just like making chocolate chip cookies. I probably made those 1,273 times in my lifetime, and I can do it without the recipe now. Don't even have to have the recipe in front of me, and that's what will happen with this formula. Once you practice it enough, you won't even have to look at the formula. You'll just know how to solve the problem. In Algebra 2, you're going to learn that the number underneath the square root is going to be called the discriminant. It's going to end up being called the discriminant. So we're going to get 36 minus 4 times 7 times 1, which is 28 all over 14. And then we're going to get negative 6 plus or minus. And what's the discriminant or the number under the square root going to turn out to be? 14? What's 36 minus 28? 8? You may disagree with 8? Tyler, you disagree with 8? No. Are you telling me to slow down?
I just had a look.
Oh, you had a look?
I have a 1 6 no.
There we go. Okay, so I picked this problem for 2 reasons. The first reason I picked it was because it was not set equal to 0, and I wanted you to see a problem that wasn't set equal to 0. Okay, so you have to move everything over. The other reason I picked it is because 8 is not a perfect square. And so this ties into what you did last night for your homework. So 8 is not a perfect square, right? 2 times 2 is 4, and 3 times 3 is 9, and 8 gets left out. It's not a perfect square. So you're going to have to simplify the square root of 8 by finding a factor of 8 that is a perfect square. What's the largest factor of 8 that is a perfect square? 4. So you're going to rewrite 8 as 4 times 2. Then in your next step, you're going to take the square root of the 4. And what's the square root of 4 going to be? 2. And 2 is going to come out. And the other 2 is going to stay underneath the square root. So the square root of 8 simplifies to be 2 square root of 2. The square root of 8 simplifies to be 2 square root of 2. And all of that is still divided by 14. Alright, so here's your next deal. You've got to look at the 6, the 2, and the 4. And you've got to ask yourself, 6, 2, and 4, will those 3 numbers reduce? Is there a number that goes into 6, 2, and 14? 14. 6, 2, and 14. 2. Victoria says 2. Y'all agree that 2 goes into 6, 2, and 14? So sometimes when you get to this step, your problem will reduce one more time. Sometimes you're finished. If there's not a number that will go into 6, 2, and 14, then that's your final answer. Okay? Because we can't do negative 6 plus a square root. So this is your final answer unless the 6, the 2, and the 14 will reduce, and it will reduce in this problem. So our answer is going to be negative, what? 3 plus or minus 1 square root of 2, or you could just have the square root of 2. You can put the little 1 in there if you want to, but it's actually understood. And then the bottom's not going to be 14 anymore because we're going to divide 14 by 2 and we're going to get 7. And believe it or not, as ugly as this looks, this is your final answers. And it's actually 2 answers because of the plus and the minus. It's actually 2 different answers.